So to construct a confidence interval for a population proportion, what you do is you use your sample proportion, which our textbook uses pi plus or minus z times the standard error of the population proportion. So standard error, the population proportion standard deviation. So you do p. Oh, sorry, they're using this one though. And this value right here, you're just plugging in. Oh, I'll show you in just a second. It's going to be 20 divided by 59. But that's the confidence interval formula, similar to the confidence interval formula for a mean. But so our sample proportion, you take 20, because let's see, ask for cash back. So you take the number that you're interested in, divide by the total. There's 59 total. And if we simplify that, that's 0.39, sorry, 0.3389. 8. So we plug in 0.33898. We'll round the decimals at the end. This z value is just like we've done in the previous videos. Just a quick demonstration of what that is. If you want a 90% confidence interval, then that means you want 5% in the tails. And in most z-score calculators and tables, they would only tell you the area to the left. So you're going to want to look up 0.95 in those calculators. Let's see. I'm going to Google search percentile to z-score calculator. And the first one that comes up is the one I like. So I'm not typing in 0.90, I'm typing in 0.95 because of that reason. And textbooks round here to 0.65. Okay, so I'll use 0.65 for that z-score. So erase that z-score. Sorry, 1.65. I think I was saying 0.65. And then up here, that's 0.33898. Then it's 1 minus 0.33898. Then you divide that by the sample size, which is 59. That sample size is inside the square root, so watch out for that. So if I was to do this with a calculator, I mean, if it's my first time doing it, I'd probably do it step by step because there's some numbers we could drop on accident. So we could subtract those first. 0.66102. That's 0.66102. It's all over 59. And here we can do inside the square root altogether. Take those two numbers in the top of that fraction, multiply them, and divide it by 59. And then we want to square root that result. So this is what I've got for the standard error. I've copied and pasted it. So now we need to multiply that by 1.65. So this is called the margin of error. Everything to the right of that plus or minus symbol is the margin of error. So just like with all the other questions, when you calculate a confidence interval, you do it twice. Once for minus. It says the 4 decimal places, so this one rounds up. And then once for plus. One zero one six eight 39. So 0.4407 when we round to the 4th decimal place. So that's our 90% confidence interval. Can the normality of p be assumed? You got to check the criteria we showed in other videos. You got to do your sample proportion times your sample size. Make sure that's greater than 10, and it is. And then do 1 minus your sample proportion times your sample size, and that's also greater than 10. So this one, yes, we can assume normality.